1.3 Chemical bonds. So a chemical bond is the link of two atoms through the transfer or sharing of one or more electrons. So those are two very important words here. Most atoms, except inert gases, will tend to form molecules to satisfy their needs in electron configuration. That's configuration. So they're all noble gases wannabes. They try to get the electron configuration of the noble gas the nearest to them. And all atoms try to bond with other atoms in order to have the last shell full. For most, this means to have 8 electrons on the last shell. Exceptions about the 8 rule, you have hydrogen, helium, lithium, beryllium, boron, and carbon, which would have full shells with only 2 electrons because the maximum number of electrons on the first orbit is just 2. And there are generally 2 kinds of chemical bonds. It's either ionic or covalent. Let's begin by the ionic bond. So this is the type that happens when there is a transfer of one or more electrons from one atom to another one. And an ionic bond happens between a metal and a non-metal. So this is a very important clue. When you're asked to recognize, is it ionic or is it the other kind? Look at the substances present. Is there a metal in front and then a non-metal? Well, then that's an ionic bond. And the metal always gives electrons. Remember, in those notes we've said that in group 1, 2, and 3, we have mainly metals there. They always gain a positive charge because they always give away electrons. So for example, the ion Na+ and the ion Cl- would form NaCl, that's table salt. And magnesium 2+ and hydroxide, which is a polyatomic ion, would form magnesium hydroxide, MgOH2. Number 3, the ion of calcium 2+, the ion of phosphorus 3- would form Ca3P2. And the last example is special because I used the exception. NH4+ is the only polyatomic ion that can take the role of a metal, right? All these guys here, so far, they're all metals. So the metal is always first. It's always the positive ion, but not here. You have 2 non-metals forming a positive ion and another polyatomic ion, chromate, and together they form NH4 2CrO4. Let's see if you can represent an ionic bond using the Lewis diagram or notation. So it goes like this. For Na, you draw your Lewis notation. There's only 1 valence electron, and for chlorine there are 7. Now remember, we said that the metal will give its electrons all the time, so every valence electron that you have must be given away by the metal. And the non-metal will always gain electrons. So in total, what do you get? Na and Cl very close to each other, forming a chemical bond. Around Cl, you need to have the 8 valence electrons, because now the last shell for Cl is full with 8. For sodium, it seems to be empty, but remember that underneath there is another full shell for sodium, and they've acquired charges, so it's very important that you write the charge for each of them, and that explains why they would stick together after exchanging their electrons like that, because they're both satisfied. Why would they stick together? Because they now have opposite charges, and opposite charges attract each other. Next example, CaO, so calcium oxide. Calcium is in group 2, and it's a metal, so 2 valence electrons, so it must give away both electrons. And oxygen has 6 valence electrons, so to be like a noble gas, it must get up to 8 electrons, so it's getting those 2. So in the end, you have Ca2+ and oxygen -2. On the left, MgF, so magnesium fluoride. Magnesium is in group number 2. It's a metal, so 2 valence electrons, so it must give both. So if we start by giving 1, this fluorine is satisfied. But hey, we have 2. You must draw 2 if there are 2 in that formula. So I need to draw a second one here. And that answers another question. Where am I going to put that other valence electron? I need another fluoride for it. So it's going to gain 1 electron. So both fluoride ions gain 1 electron, so they're negatively 1 charged, but magnesium gets rid of both, so it's positive 2. And finally, Ca3N2, calcium nitride. You need 3 calcium and 2 nitride ions. So let's go like this. Calcium can give 1 here and 1 here. Now, this calcium is done. The metal gave all its electrons away. But that nitrogen is not okay. Now it has 1, 2, 3, 4, 5, 6, 7. There's still a spot here that's empty. So you need another calcium. 1 and 2. So now that calcium is satisfied. That nitride is satisfied, but not the last 2. It still has 1 and 2 spots. So I need 2 more electrons to fill it up. That's why I need so many calcium, and that's why I need so many nitride. And in the end, you're going to get this. You need to represent each charge. It must be written for each ion. And second, we have covalent bonds. So the covalent bond happens when 1 or more electron pairs is shared between 2 atoms. So this time it's a sharing relationship between the 2 components. Instead of transferring, right? Ionic is a transfer, covalent is sharing. So a covalent bond happens between only non-metals. You will not see a metal in there, so you have to look for non-metals bonding for a covalent bond to happen. For example, carbon and dioxygen will give us CO2, carbon dioxide. 2 hydrogen atoms would become H2. And that's also 2 nonmetals, right? I know they're the same, but it's still nonmetals, so H2 is formed by a covalent bond. And phosphorus and chlorine 3 times would form phosphorus. It's called actually phosphorus trichloride, if I want to say this properly, phosphorus trichloride. You also need to be able to represent covalent bonds with a Lewis diagram. So the method is almost the same. You'll see what the difference is. And note that on this page, we never write the charges. In covalent bonds, there are no charges. So first you draw your chlorine, and there are 2 of them, so I have to draw 2 chlorine atoms, and they're going to bond. So their goal is to have 8 around. So here's how I'm going to count. We have 1, 2, 3, 4, 5, 6, 7, and 8. I have to count that one because the circle around means that this is the pair of shared electrons. So I have to count it for both. When we share something, it belongs to both of us. And 1, 2, 3, 4, 5, 6, 7, and 8 for that one too. So they both have 8. And I want to finish by drawing my ball and stick model. And here, the line in between represents the pair of shared electrons. So 1 line, 1 pair. Let's try Br2. So first, I can draw the covalent bond with the Lewis diagram. Again, it's the same. Br2 is just like Cl2. Actually, they are atoms from the same group. So they both have 7 valence electrons, so that's why they're going to form their bond the same way. And 1 pair is shared, 1 line on the ball and stick model. Let's try methane gas, CH4. Carbon is in group 4, so it has 1, 2, 3, 4 valence electrons. And hydrogen in group 1 has 1 only. Remember that for hydrogen, having 2 electrons is a full shell because that's orbit number 1. It's full with 2. So let's count. Does that work? Do I really have 8 around carbon? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that works. And you can see that you have 2 for each hydrogen as well. So everyone is satisfied like that. And then you replace each bond by a line, and you have your ball and stick model. And finally, CO2. Again, carbon has 1, 2, 3, 4 valence electrons. Oxygen has 6. So what's oxygen trying to do? It needs to form 2 bonds, because 6 plus 2 will give him 8, so it needs to form 2 bonds. But for carbon, 4 plus 4, so it's going to need to get 4 bonds around carbon. So I need to see 4 bonds around carbon and 2 bonds around oxygen. Let's see if that can work. I have 1, 2 bonds around that oxygen. Around that oxygen I have 1, 2 bonds, and around carbon I have 1, 2, 3, 4 bonds. And count your electrons. Let's try to do this oxygen. 1, 2, 3, 4, 5, 6, 7, 8. It does have 8 around it, so that works. And when you draw your ball and stick model, you need to have a double line, because there are 2 pairs on each side. We also need to be able to predict the bond, but that's for ionic only. What if you were just told which 2 elements were going to form a bond? How can you predict exactly how many of each atom will be used? You would need to find their ionic charge. For example, if sodium and chlorine meet in a test tube, remember that even in a tiny sample, billions and billions and maybe trillions are present. What will be the correct formula for them? So first, the ionic charges. So Na is +1, it's a metal from group 1, and Cl is, that's -1 from group 7, right? 7 to get to 8, you need 1 more electron. So -1 comes from the fact that it tends to gain a 1. And I did that here. I'm showing that here. It's going to gain a 1, and then it will have a complete shell, and you're going to get NaCl. So in that case, 1 Na and 1 Cl works fine, because 1 sodium has 1 electron to give, and 1 chlorine has 1 spot for a new electron. So 1 of each works just fine in that case. So let's look at a few general rules to be able to do this exercise with any metal and non-metal. First, the octet rule. It means that atoms combine to have 8 valence electrons on their last orbit. Remember, for some of them it's going to be 2, but for most it's 8. What does the metal do always? We said metals give electrons, so they are always positive ions. And how do I predict the charge of the metal? Now, the charge is equal to your group number, and that's it. For example, magnesium, which is a metal, is in group number 2A, so the charge is positive 2. Positive because it's a metal, and 2 because it's in group number 2. Now, what does the nonmetal do in that case? Well, it always gains electrons, so it's always a negative ion. And how do I predict the charge of the nonmetal? Well, the charge for a nonmetal is 8 minus the group number. So for fluorine, for example, which is in group 7A, I'm going to do 8 minus 7, which is 1. And now the charge is going to be -1. The charge is -1 because it's a nonmetal. Remember, it's gaining a new electron, so the total is -1. And we have a nice little trick called the crisscross trick. Let's see if we want to take calcium and chlorine. How do they bond? Is it going to be CaCl, Ca2Cl3, something? What is it? Well, we need to find their charges. So first, you write both ions with their charges, and you crisscross. You switch the charges. That's it. So Ca1, Cl2. So the right way to write it in the end is CaCl2. You do not write the 1. When it's a 1, you get rid of it. And note that we lost the charges, and the plus and the minus, we don't write them in the final formula. Now, how about aluminum and oxygen? Aluminum is 3+ in group 3. Oxygen group 6, that means 2 negative, and it's a nonmetal, so it's negative. Switch the charges, it's Al2O3. Potassium and NO2 negative 1. Plus 1, negative 1. So switch your charges, you have one of each. Now, you really need to write that 2 here, though, because that 2 means that you have 2 oxygens with 1 nitrogen, and that polyatomic ion, it must remain like that. This is always NO2. You cannot change what that is. You could have many NO2s together, but it's always NO2. And finally, beryllium and PO4 3 negative. Beryllium is 2 plus, PO4 is 3 negative. Switch the charges, Be3, PO4 2.